Okay, everyone, let's continue looking at Module 26202-23, Motor Theories and Applications, in the NCCR 11th edition. This will be Section 3.00, Variable Speed Drives. Variable speed drives. Reliability, cost, and control capabilities are major factors in system selection. A drive system includes the drive controller and the motor being driven. Most drive controllers can be adjusted or modified to optimize performance. It is important to know the load speed and torque characteristics and horsepower requirements. Constant torque loads require a constant torque with horsepower varying in proportion to speed. Variable torque loads require lower torque at lower speeds. Constant horsepower loads require high torque at low speeds and low torque at high speeds. Motors can also function as generators or brakes. To function as a generator, a motor absorbs mechanical power and converts it into electrical power. To function as a brake, converted electric power is dissipated as heat. Here are some examples of a typical torque speed curve. Motor heating. When operating a motor at reduced speeds, the ability to dissipate heat is also reduced due to the slower cooling fan speed. To understand how a drive controller varies speed, you must know how AC or DC motor speed can be varied. To vary the running speed of a DC motor, you can adjust the voltage applied to the field winding or adjust the voltage applied to the armature. Varying the speed of an AC motor. For a standard AC motor, the principle of speed control is based on this formula. The frequency output of a controller is adjustable over its designed speed range, so the speed of the motor is adjustable over the same range. When variable frequency speed control is employed, the motor supply voltage must be increased or decreased in proportion to the frequency. The stator's magnetic field strength must remain constant under all operating conditions. The magnetizing current for an induction motor is given by Ohm's law. Note that the controller can automatically maintain the required volts, cycle, hertz ratio to the motor at any speed. The volts hertz setting is generally preset at the factory, but often can be adjusted. Braking methods. General injection braking or dynamic braking are the most effective braking types for motors. DC injection braking occurs when DC is applied to the stationary windings of an AC motor after the AC voltage is removed. This type of braking provides a quick and smooth braking action on all types of loads. In an AC induction motor, when the AC voltage is removed, the motor will naturally coast to a stop over time. The stopping time for DC injection braking is based on the amount of DC applied. No parts come into contact during DC braking, so maintenance is kept to a minimum. Dynamic braking is achieved by reconnecting a running motor to act as a generator immediately after it's turned off. This type of braking may be needed because DC motors are often used to lift and move heavy loads that can be difficult to stop. The smaller the resistance of the resistor, the greater the rate of energy dissipation and the faster the motor slows down. The braking action lessens as the speed of the motor decreases. Note that dynamic braking cannot hold a load once it is stopped, so this type of braking is often used in combination with electromechanical friction brakes. And there are no trade terms for this section, but there are some review questions for this section. With a constant torque load, the horsepower varies in direct proportion to the speed, varies inversely with the speed, remains constant, or lags the speed by 10%. I'm going to say varies in direct proportion to the speed. When variable frequency speed control is used on a motor nameplate rating of 480 volts at 60 Hz, the voltage to frequency ratio is 8. When using a motor with dynamic braking, the field windings are disconnected during the braking action. Electromechanical friction brakes may be required with large loads. The braking action can be used to hold a load after it has stopped. A large load can be braked to an immediate stop. And we're going to say electromechanical friction brakes may be required with large loads. All right, everyone, that's it for that section. The next section will be 4.00, motor enclosures, frame designations, and operating characteristics, and I will see you over there.